circuit something like this. And with this we say this is R1, this is R2, this is C1, and this is C2. With that we have a resistor in the emitter leg, which we normally say as RE, and over here we say this is RC. Now as we are doing the AC analysis, so we would like to have also the voltage source that needs to be connected in the circuit. And when we connect the voltage source inside the circuit, we have something like this, the voltage source which is being connected in the circuit, right? As well as we have a capacitor that is being connected in parallel to the emitter resistance. Okay, can you hear me?
Yes, sir.
Okay, Ji. So if you see, we have a circuit something like this, in which we have the voltage source. We say, let's suppose this is Vs over here, and with the voltage source there is a series resistance. As we have discussed, in voltage source we need to have a resistance in series to it. With that, if you see, we have the DC biasing which is being connected to the circuit, as well as we have the capacitor which is being connected to the emitter leg, and we call it as C3. Okay. Okay, so if you see, we have some input voltage which is being connected to this, and we say, let's suppose the input over here is Vi. Output which we are collecting, it is from the collector leg, which is V0, right? Now if we are looking into the system from outside, we have some input current which is flowing into the circuit. As I, and there is also an current which is flowing into the system over here, and this current is normally being called as I naught. And similarly, when looking from the input side, we have some input resistance which is normally called as Zi, and when looking from the output side, from here we have some output resistance as Z0. Are you with me up till now?
Yes, sir.
Okay, so this is basically the original circuit which we will be working with, right? Now, the first step to go ahead with the AC analysis is, for every circuit we have to do the DC analysis, right? So if we have to work with the AC analysis, so first we have to do the DC analysis, because the DC analysis provide us the point of operation of the transistor, right? So once we have obtained the point of operation of the transistor, then we will look into the AC circuit, right? So first we have to look for the DC circuit. Once we have obtained the point of operation, and the point of operation is basically the Q point, right? Once we have figured out the Q point of the circuit, then we will start working with the AC analysis, right? So for every AC analysis of any circuit, we have to do first the DC analysis, and then we will work with the AC analysis, right? So first, the all the things which we have done in the last chapter, they need to be done for the AC analysis first, and then we will do the actual AC analysis, right? So first we have to do the DC analysis, and then we have to work with the AC circuit. Okay, so how we will work with the AC circuit now? Because as you know, the now we will actually be taking out the DC components from the circuit, right? And the first DC component of the circuit is, if you see, we have VCC. VCC is basically the biasing voltage, and the biasing voltage is actually being used to locate the Q point or the point of operation of the circuit. So first what we need to do, we need to actually get rid of the DC components which are there in the circuit, right? So if there are two biasing sources, let's suppose VCC and VEE, so we need to remove both of them, because we have already utilized their usefulness by obtaining the Q point. So once we have obtained the Q point, then what we need to do, we need to start working with the AC circuit. And the first step in the AC circuit is, we have to get rid of all of the biasing sources which are being connected inside the circuit, right? So the first thing is, we need to remove the biasing sources. Okay, the second thing, if you see, we have the capacitor C1 and C2, right? C1 and C2, they are called the coupling capacitors. And what is meant by coupling capacitor? They are actually coupling, if you see, they are coupling the voltage source to the circuit, which is the C1, and C2 is actually coupling the circuit to the output, right? So C1 capacitor and C2 capacitor, they are basically called as the coupling capacitor. And if you see, we have another capacitor which is being connected to in parallel to RE. Now this is basically called C3, is called the bypass capacitor, because for DC the capacitor will be behaving as an open, right? So when it is behaving as an open, so this means RE is there for the DC analysis. But if we go for the AC analysis, if we go for the AC analysis, ओके जी, आवाज आ रही है जी?
Yes, sir. अब आ रही है.
ओके जी,
बाई
सो
बाईपास में से.
आवाज आ रही है जी?
Yes, sir. आवाज आ रही है.
Okay ji. So for the analysis, or what we have to do, first we have to do the DC analysis, and then we will start working with the circuit for the AC analysis. So the first thing is we need to take out the biasing sources, and let's suppose one of the biasing source is VCC, so we will take it out. And once we will take it out, so this means the R1 and RC, one of the ends, they will be connected to ground, right? Are you with me? When we take out
Yes,
VC
sir.
from the circuit for the AC analysis, one end of R1 and one end of RC will be connected to ground, right? Are you with me?
सर तो आपस में तो कनेक्टेड है, तो फिर ग्राउंड के साथ क्यों कनेक्ट है?
जब हम बायसिंग सोर्स निकाल देंगे, तो ये जो है, क्योंकि वीसीसी का दूसरा एंड जो है वो ग्राउंड के साथ कनेक्टेड है, ठीक है, जो डीसी सोर्स है. आर यू विद मी?
Yes, sir.
So therefore when we take it out this thing, so R1 and RC, their one ends, they will be connected to ground, right? Now we come towards the capacitor C1. If you see the C1, when it is working for AC, it is behaving as having very low reactive resistance. Let me just redraw the circuit, what we are going to get from here. If you see, we have in the middle is the transistor, which is like this, which is base, collector and emitter. And with this, if you see, we have the resistance which is being connected to the collector is RC. With the base, the resistance which is connected is R1, as well as we have R2 over here, right? And the other end of the R2 was already being connected to the ground. If we see, taking a look of the previous circuit, so R2 is already connected to ground, R1 is connected, with the other end is the DC source. So as we are going to take out the DC source from here, So what is being left with us is that R1 other end will be connected to ground. Similarly, RC other end will be connected to ground. And when we check it out the C1, so C1 will be behaving as short circuit over here, as well as C2 will be behaving as short circuit over here, right? And with that, if you see, we have the RE resistance, and RE resistance is having the C3. Now when C3 for AC, it will be behaving as short circuit, and when it will be behaving as short circuit, so this means RE in parallel to C3, it will work as
शॉर्ट सर्किट
short circuit, right? So this
जैसे
means
सर जल जाएगा.
E3 will be directly connected, EE will be directly connected to the ground, right? As well as if you see, we have the uh, voltage source. So voltage source will be now connected over here. On this side we have this with the voltage source, and it is being connected to ground. So we have Vs, we have Rs, and if you see, the current flowing over here is II, and looking from here we have Zi over here, and looking from this side we have the current which is flowing over here is I naught, and looking from this side we have the Z naught, which is going to be the output impedance and the output current which is flowing out. Okay, are you with me?
यस
सर ये
सर
ऑन
जी
था, वो
ये
तो
आप
कैपेसिटर पे जा रहा था. अभी ये
आर
ऊपर
ई
गया.
जो कैपेसिटर लगा हुआ था उसको आपने हाई पास बताया था, कुछ बताया था तो आवाज चली गई.
मैंने ओके, आर ई के साथ जो कैपेसिटर लगा है दैट इज कॉल्ड बाईपास कैपेसिटर.
बाईपास. यस.
Bypass capacitor means it is going to bypass the circuit for the AC, and it will allow the things to pass through it for DC. So for DC this means RE will be there, and for AC RE will not be there, because RE will be just working as short circuit due to the C3 capacitor. Are you with me?
यस सर.
यस सर.
Right? So if you see, we have now a much simplified circuit over here. We have something like this, and now with the transistor we have R1 and R2. If you see, I make it much more simpler. Let's see, this is the circuit which we have. So R1 and R2, they are both connected to the base of the transistor, right? And similarly RC is connected to the collector of the transistor, and similarly we have working as a thing which is called, we are working with a system that is having the input current as well as the input voltage, as well as we have the input output current, as well as we have, if you see, from the collector we have we have the output voltage over here, right? So if we summarize this circuit, so how this circuit will be looking as that, we have basically we have basically a system which is having, if you see, we have a system which is having some two ports, and in between the two input ports we have a current which is flowing into the system as II, and the voltage which is being applied over here is Vi. And when looking into the system,
मला मग एक जाऊन पेंड मसाल्याला यार.
ना
हेलो जी, आवाज आ रही है?
यस सर अब आ रही
अब आ रही है सर.
अच्छा जी, okay. So what we are actually looking at, we are looking at a system which is having two input ports and two output ports, right? So two input ports, we have basically the current which is flowing into the system as II, and the voltage which is being applied between the two input ports is Vi. And when looking into the system, we see an input impedance as Zi. And similarly, when we take a look from the output side and looking into the system, so the current is flowing into the system as I naught. And similarly, from the output side, the voltage which is being obtained is V naught. And when looking from the output side, the impedance of the system is Z naught, right? So it is basically two input ports and two output port system, in which we have the current which is flowing into the system from the input side is II, the voltage which is being applied in between the two input ports is Vi, and when looking into the system, the input impedance is Zi. And similarly, from the output side, the current will be flowing into the system as I naught. When looking from the output side, the impedance will be equal to Z naught, and in between the two output ports, the output voltage will be equal to V naught. If the direction of the current changes, so this means a negative sign will be applied to the current, and if the direction of the voltage changes, so again the negative sign will be applied either to the input side or either to the output side. Are you with me?
यस सर
So
रिपीट करायचं.
G,
यस सर.
सर रिपीट करायचं जरा.
okay, so what we are saying, that we will be every time taking the things that they are according to this system, right? So if you see the system over here can be, if you just try to analyze this AC circuit with that of the system which I have just shown you, right? So what we say over here, that this is basically the system, right? The system has two input ports and two output ports, and the system has the input current which is flowing into the system, as well as the system has the input voltage between the two input ports. And when looking from outside into the system has the input impedance equal to Zi. So what we say, let's suppose when looking from here, what we say, we check it out and the value is, let's suppose, Zi. And similarly, when looking from the output side, we see that the output current is actually flowing into the system, right? So these parameters are basically the requirement for the system that we want to analyze, right? So we actually are not able to change the directions of the current for the system. But if the direction for the system which we are going to analyze have some different directions, so the negative sign will be applied to those currents or voltages, right? So for the system that needs to be analyzed, the direction of the currents and the direction of the voltages will be like this. But if when it is going to be implemented, let's suppose the same thing is going to be implemented on the circuit which we are just analyzing, the AC circuit, so we will see how the direction of currents and how the direction of voltages they are going to behave, right? So if we see over here the I naught, so I naught is actually flowing into the system with the Z naught over here as the impedance looking into the system from output side. Okay, and similarly the voltage over here is, this is the positive sign, this will be the negative sign for the voltage. But if the direction of the voltage is they reverse, the voltage will have a minus sign with that thing, right? Are you with me now?
Yes, sir.
Okay, similarly, if you see, this is the circuit which we have now, right? So what we can do, we can summarize this circuit, or we can simplify this circuit. And how we can simplify this circuit, let's see. So if you see, we have in the middle we have a transistor, right? So we have the base, emitter, and we have the collector, right? So at the base we have basically R1 and R2, they are connected, and we can see from here that at the base we have R1 and R2 which are connected, and we have the RS and the voltage source, they are also connected, right? So what we can see, that at the base we have R1 and R2, they are connected. So we can connect R2 as well as we can connect R1, right? And the third thing is